Welcome to this expert-level training on responsible AI. Today we are focusing deeply on the principles of fairness in AI solutions. Welcome everyone to this essential training session on the principles of responsible AI, with a specialized focus on considerations for fairness in AI solutions. As artificial intelligence becomes deeply integrated into business and society, we must ensure these systems operate ethically. According to our documentation, responsible AI is a term used to describe considerations for building AI systems that include specific guardrails. These guardrails are critical to mitigate the risk of harmful, illegal, or offensive content generation and prevent dangerous automated actions. Because AI systems are based on probabilistic models, they are not infallible. Therefore, developers must implement a comprehensive framework of governance. The core principles of responsible AI include fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. While all these pillars are vital, our primary focus today is fairness. Understanding fairness is the first step toward preventing systems from producing discriminatory outputs. We will explore the root causes of bias, examine how data selection impacts AI behavior, and discuss how developers must minimize bias in training data. While there is no specific application logic to execute here, developers must translate these responsible AI concepts into programmatic guardrails. In practice, this means integrating content filters, bias detection algorithms, and safety evaluation metrics directly into your application's architecture to ensure the AI behaves exactly as intended. Take a look at the flowchart displayed on the screen. This diagram visually maps out the foundational concept of responsible AI as described in our training materials. At the center, we have the core AI system, which is surrounded by necessary guardrails. These guardrails actively filter and process the system's actions to mitigate risks. By implementing these protective layers, the system successfully prevents harmful content, illegal actions, and offensive outputs, ensuring a safe experience. Moving forward, we must address the fundamental definition and origin of fairness considerations in artificial intelligence. The principle of fairness recognizes a very crucial reality about machine learning. AI models do not learn in a vacuum. Instead, AI models are trained using data, which is generally sourced and selected by humans. This is where the core challenge lies. Because humans are involved in the data collection and curation process, human perspectives inherently shape the foundation of the AI's knowledge base. If the data selection criteria are flawed, the entire AI solution is compromised from the start. As an AI developer or architect, you must constantly evaluate where your data comes from, who collected it, and what criteria were used to filter it. The data selection process is just as critical as the algorithms you choose. When we talk about fairness, we are talking about ensuring that this human element does not introduce unfair advantages or disadvantages into the AI system. Recognizing that human-sourced data is the primary vehicle for potential unfairness is the most important step in building an equitable application. The integrity of the AI system relies heavily on rigorous, objective data curation practices that actively seek to eliminate blind spots. In the context of data sourcing, your codebase will often reflect your data selection criteria. For instance, when querying a database to build a training dataset, the SQL or Python logic used to filter records must be scrutinized. Developers must ensure that their data extraction queries do not inadvertently exclude specific demographics or overrepresent certain groups. This flowchart illustrates the critical pathway of data from human curation to AI processing. It starts with human data sourcing, moving into the data selection criteria phase. From there, the curated data becomes the training data that feeds directly into the AI model. This visual emphasizes that the AI model is entirely dependent on the preceding human-driven steps. If there are flaws in the selection criteria, those flaws are absorbed directly by the model, impacting fairness. Now that we understand the human role in data sourcing, we must explore the specific mechanism that compromises fairness: unconscious bias. According to our training materials, there is a substantial risk that the data selection criteria, or the data itself, reflects unconscious bias. Unconscious bias refers to the underlying stereotypes or attitudes that people unknowingly hold, which inevitably bleed into the datasets they create. When an AI model trains on this biased data, it learns to recognize and replicate those exact same biased patterns. Consequently, this may cause a model to produce discriminatory outputs. A discriminatory output occurs when the AI system treats individuals or groups unfairly based on those learned biases. This is a severe failure of the responsible AI framework. For example, if historical data favors one demographic over another for a particular job role, an AI trained on that data will likely discriminate against the underrepresented demographic. It is crucial to understand that the AI is not intentionally malicious. It is simply mathematically reflecting the unconscious bias present in its training environment. Detecting unconscious bias in code often involves analyzing the statistical distribution of your training data. Developers should implement scripts that calculate the representation of different groups within the dataset. If the code reveals a significant imbalance, it serves as an early warning sign that the data selection criteria may be flawed and that the model is at risk of generating discriminatory outputs. Observe the workflow presented in this diagram, which maps the propagation of bias. We begin with unconscious bias, which actively influences both the data selection criteria and the raw data itself. These compromised inputs feed into the AI model training phase. Ultimately, the model processes this biased information and generates discriminatory outputs. This visual clearly demonstrates how unchecked human biases cascade through the entire technical system to negatively impact the end user. Understanding the risks of unconscious bias brings us to the actionable responsibilities of the technical team. The Microsoft Learn documentation explicitly states that AI developers need to take care to minimize bias in training data. This is not a passive requirement. It demands active, deliberate intervention throughout the machine learning lifecycle. Minimizing bias begins during the data preparation phase. Developers must rigorously analyze their datasets to identify imbalances or skewed representations. If certain groups or scenarios are underrepresented, developers must take corrective action, such as gathering more diverse data or using specific sampling techniques to balance the dataset. It is your ethical and professional duty to question the integrity of the data you are using. You cannot simply accept a dataset at face value and assume it is neutral. By actively taking care to minimize bias before the model ever begins training, developers establish a strong foundation for a fair AI solution. This proactive approach is the most effective way to prevent the discriminatory outputs we discussed previously, ensuring the system serves all users equitably. Remember, fairness is an ongoing commitment, not a one-time checklist item. From a coding perspective, minimizing bias involves implementing data preprocessing routines. Your Python or data manipulation code should include steps for data balancing, such as oversampling minority classes or undersampling majority classes. Additionally, developers can write validation functions that halt the training pipeline if the dataset fails to meet predefined diversity and fairness thresholds. This diagram outlines the proactive mitigation strategy for developers. It begins with the AI developer, whose primary responsibility is to analyze training data. The next critical step is to minimize unconscious bias through data balancing and curation. This leads to the creation of clean, balanced data, which is then used for model training. The final result of this careful process is the deployment of a fair AI system that adheres to responsible AI principles. Minimizing bias in the training data is incredibly important, but it is only half the battle. Because AI systems are based on probabilistic models, they are not infallible. They make predictions based on probabilities, which means unexpected or biased behaviors can still emerge during operation. Therefore, the training material emphasizes that developers must actively test AI systems for fairness. Testing for fairness involves evaluating the model's predictions across different demographic groups and scenarios to ensure consistent and equitable performance. You must proactively search for disparities in how the model handles varying inputs. For instance, does the model have a higher error rate for a specific group of people? If so, the system is failing the fairness test. This testing must be rigorous, systematic, and integrated into the standard quality assurance processes of the software development lifecycle. By continuously testing the AI system, developers can identify and correct biased outcomes that were not caught during the initial data curation phase, thereby upholding the core principles of responsible AI. Robust fairness testing acts as the final safety net before an AI application reaches the hands of the public. Testing for fairness requires specific evaluation code. Developers utilize fairness metrics and evaluators to score the model's output. Your code might segment the test dataset by different demographic attributes and calculate the accuracy or error rate for each segment individually. If the code detects a significant variance in performance between segments, it indicates a fairness issue that requires immediate retraining or prompt adjustment. The flowchart on screen displays the continuous testing loop for AI fairness. It starts with the trained probabilistic model, generating AI predictions. These predictions move into the fairness testing and evaluation node. Here, the system checks for disparate impacts. If biases are found, the workflow loops back to adjust data and retrain. If the evaluation passes, the system moves forward as a verified fair AI solution, ensuring equitable operations. To solidify our understanding of fairness, let's examine a concrete, real-world example directly from our source materials, an AI-powered college admission system. In this high-stakes scenario, the AI application is tasked with reviewing student applications. To adhere to the principle of fairness, the system must be rigorously tested to ensure it evaluates all applications fairly. How does it do this? The AI must make its determinations strictly by taking into account relevant academic criteria, such as grades, test scores, and relevant extracurricular achievements. Simultaneously, the system must be explicitly designed and tested to avoid unfounded discrimination, based on irrelevant demographic factors, such as race, gender, or geographic background. If the model's training data contained historical biases where certain demographics were favored, an untested system might penalize highly qualified applicants simply based on their background. By applying the fairness principles we have discussed, minimizing bias in the data, and actively testing the outputs, the developers ensure the college admissions system remains objective, equitable, and responsible. This scenario perfectly illustrates why fairness is not just an abstract concept, but a crucial, functional requirement. In a college admissions application, the feature engineering code is paramount. Developers must explicitly exclude irrelevant demographic data from the model's input features during training. The code should strictly pass relevant academic metrics to the inference engine. Furthermore, fairness testing scripts would evaluate the model's acceptance rates across various hidden demographic groups to verify true neutrality. This diagram maps the logic of a fair AI college admission system. The process begins with the student application data. The workflow branches into two paths. Irrelevant demographic factors are explicitly blocked and excluded, while relevant academic criteria are passed to the AI evaluation engine. The engine processes these valid metrics to produce a fair admission decision, perfectly illustrating responsible AI design and practice. As we conclude our deep dive into fairness within responsible AI, we must tie these concepts back to the broader principle of accountability. Ultimately, the people and organizations that develop and distribute AI solutions are accountable for their actions. You cannot blame the machine for unfair or discriminatory outputs. The responsibility rests entirely with the developers and architects who built it. It is absolutely essential for organizations to define and apply a strict framework of governance to help ensure they consistently apply responsible AI principles to their work. By establishing clear policies around data sourcing, bias mitigation, and rigorous fairness testing, teams can build transparent, inclusive, and reliable AI systems. Thank you for joining this comprehensive training session on AI fairness. We hope this deep dive has empowered you to build more ethical technology. Please invite your peers to like and subscribe to our channel for more expert technical content. Be sure to visit quicktechie.com for premium certification prep, including comprehensive Q&A banks, ebooks, audiobooks, advanced training modules, and interview guides. To succeed in today's landscape, mastering these ethical frameworks is just as important as mastering the technical code itself. By prioritizing fairness, we build trust with our users and society at large. Accountability in software development means maintaining clear audit trails and version control. Your codebase should implement robust logging mechanisms that track which data was used for training, what fairness metrics were recorded during testing, and who approved the model for deployment. This code-level traceability ensures organizational governance is actively enforced and verifiable. Our final flowchart visualizes the overarching concept of accountability. It starts with the organization and developers, who are responsible for establishing a governance framework. This framework enforces the application of responsible AI principles, specifically focusing on fairness and bias mitigation. This structured approach ultimately leads to the successful deployment of ethical and accountable AI systems in the real world.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.